Avogadro's number. What is it? How does it work? And how do you use it? The number is basically 6.022 times 10 to the 23rd. And that's referenced to mole. It tells you how many atoms there are in 1 mole of any given substance. So you can think of the term mole like the term dozen. 1 dozen of something equals 12 somethings. 1 mole of something equals 6.022 times 10 to the 23rd somethings. So you have a dozen eggs, that's 12 eggs. If you have a mole of eggs, that's 6.022 times 10 to the 23rd eggs. Keep in mind this is a huge number. Of course, it was invented by an Italian scientist named Avogadro. It was confirmed by a scientist named Robert Millikan, who worked with moles of electrons. So let's say you want to know how many atoms are there in 1.3 moles of carbon. Just for an example. You start with 1.3 moles of your carbon. What you're going to do is you're going to multiply that by Avogadro's number. What I've set up here is a conversion factor. Avogadro's number on top, moles on bottom. I put moles on bottom because I want these to cancel out and I want to get to atoms. You always put your unknown on top of a conversion factor. So moles will cancel. So basically what you're doing is 1.3 times Avogadro's number in a calculator. That gives you 7.83 times 10 to the 23rd atoms of carbon. So the great thing about Avogadro's number is you can find out how many atoms are in a given substance. Now what if you start with grams? You had to weigh out a mass of something and you got its grams, but you want to know how many atoms are there in that mass. Let's say 25 grams of iron, which you could weigh out on any scale in a laboratory. Well, first you got to convert grams to moles and then moles to atoms. So 25 grams of iron, we're going to go from grams to moles first. So 25 grams of iron times a conversion factor of 1 mole of iron divided by 55.85 grams of iron. So it's going to be 25 times 1 divided by 55.85. Notice grams will cancel out because grams are on bottom down here. Cancel, cancel, and we'll get whatever our result is, it'll be in moles. The reason we use 55.85 is because that's the molar mass of iron. You can find that right off the periodic table. All you have to do is take this bottom number, it's called the molar mass, and that gives you the conversion factor number you need to convert whatever element you're working with. In this case, we're dealing with iron, so we use the molar mass of iron, which again, right off the periodic table. So you plug this into a calculator, you get 0.4476, and now we have moles of iron. So now we can figure out exactly, we can keep continuing and figure out how many atoms we have in this amount. So now we started with grams to moles, now we're going from moles to atoms. So we have this many moles of iron. You multiply this number times Avogadro's number. Again, moles are on bottom, so cancel, cancel. We're going 2 atoms, the unknown's on top in this conversion factor. So it's just this number times Avogadro's number, because dividing by 1 does nothing. So whatever our result is, it's going to be in atoms. And there it is. Just plugging it into a calculator, and there you get it. I hope this helps with Avogadro's number.